He said, I'm not sure what the vertex does if it helps with flux capacitor. That's exactly what it does do. No, it does do that. It does. It inverts the plasma radiance and all kinds of things like that. The inverse matrix of it really puts us into outer space pretty easily. I love it. Truth for me works every time. So, if you have that homework sheet or if you took a picture of it, let's figure it out. If you're looking at a picture on your phone, totally cool, but I'd say it'd be important that you take notes off of it because you're just looking off on your phone. Please make sure your phone is off, though, and you're not receiving them MSGs. That's the bad sodium stuff that people will have at Chinese restaurants. Yeah.
Can we take pictures unless we have to, like...
Oh, if you want to sit and watch, take a picture of the board at any time.
All right.
You want to do that? Sweet. And then I got it recorded for you as well. Let's give a shout out to Preston on 3. 1, 2, 3.
Why are we shouting out?
There you go. So you should hear that.
Why are we shouting out?
I don't know, because he's, not here. So he'll watch it.
Preston.
And then Garvey said you took the prison bus. All right. Let's see. The directions on the assignment. The directions on the assignment said for each quadratic equation, answer the following. Will it open up or down? I'm pretty sure most people will feel pretty good about that. And then use x equals negative b over 2a to find the coordinates of the vertex, which finds the x coordinate, and you have to plug that in. And then give the equation of the axis of symmetry. And find any roots. Remember, a root is when we factor it, set each of those equal to 0, and that'll tell you exactly where across the x-axis. Complete the table of values centered at the vertex, and then sketch the graph. So there's a lot of directions here, A through F. So let's take a look at the first problem. Problem number 1 says this. Y equals x squared minus 4x plus 4. So let's go through and let's see if we can answer these questions. Letter A. Does it open up or down? Up. Why? A is positive. Where's the A value, Mac? Yeah, the value in front of x squared. So this opens up. Okay? And so something that's kind of important to do with these, and it's good practice, write your A and B, and if you want to write your C, that's also fine. So you have your A, B, and C values. Okay? And your A value, if it's a positive number, means that the parabola will open up. Are we good so far? I just don't want to do it way. Good. And then we're going to use, for letter B, we're going to use negative b over 2a. So we're going to try and answer this. Negative b over 2a. And that's going to find us the x value of our vertex. Remember, that's x and that's y. So right now we're going to be able to solve the x value by just using this, and then there's be another step. So I know that this negative has to follow along with it, so I have negative 4 over 2 times 1. Does everybody agree with how I just did that math? Anything stuck on there? Negative 4 is? Positive 4. So I get 4 over 2. 4 over 2 is? 2. So my x component of my vertex is 2. Is everybody okay with that? Do I have the vertex yet? No, I have one part of it. I know that at 2 comma something, my vertex will exist. Agree? Mm-hmm. What do you think we should do with that 2? Angela, what should I do with that 2 to find what y is equal to? Do what? Plug it in for x? Yeah, baby. So, I have this x value here. I have this x value here. I know the parabola opens upward. I know that the x component of my vertex is 2. In order to find me the y component, I know that y is equal to this. So I'm going to take whatever this value was. I'm going to find that value. I'm going to plug this in for each of my x's. So I'm going to get y equals 2 squared minus 4 times 2 plus 4. What's 2 squared? 4. So I have y equals 4. Negative 4 times 2 is negative 8 plus 4. So let's see, negative 4 minus 8 is negative 4. Negative 4 plus 4 is 0. So my vertex is at 2 comma 0. What do you think? 2 comma 0. Where does 2 comma 0 fall on the xy axis? Yeah, I'm going to go over 2 and not go up or down at all, correct? So does it fall on the x-axis?
Yes.
Okay, okay. Give the equation of the axis of symmetry. The axis of symmetry. The axis of symmetry is always x equals whatever my x value is. X equals 2. What kind of line is that other than straight? It's a vertical line, and we know vertical lines have what kind of slope? Undefined slope. Okay. So we have an axis symmetry of x equals 2. It's a vertical line. Remember, this is like the mirror, which I can fold the parabola over on top of to find the next point. Okay. D, find any roots. Oh, okay. Let's see if we can find any roots. Let's see if we can factor this down. Let's go. Our magic number is 4. It's a positive 4. But what do we know because of this?
Negative.
They're both negative. The factors of 4 are 1 times 4 and 2 times 2. Which one would work to give me negative 4 for an answer if they were both negative when I add them together? Huh? Negative 1 and 4, if I add them together, gives me negative 3. If I add them together, which 2?
2 and 2.
2 and 2, both being negative. Okay, if I were to take the 2 and the 2, and they were both negative, and I add the two negatives together, I get more negative. That gives me the negative 4. So that gives me x squared minus 2x minus 2x plus 4. What do I have in common here? X, so then I factor out x minus 2 left. Because that's negative, what do I know about my next factor? Negative, so I'm going to factor, what do these two have in common? 2. If I factor negative 2 out of negative 2x, it leaves me a positive x. If I factor negative 2 out of a positive 4, it leaves me a negative 2. So it breaks down to x minus 2, x minus 2. So what's x equal to? So x is equal to 2 is, I have this twice. These are my roots. Is that the same number? Is it the same spot on the graph? Okay. Complete the table of values with the vertex. Oh boy, oh boy, oh boy. All right, let's see. I think I can, maybe. Full screen, dual page display. Oh yeah. What? All right. Yeah, we got fancy. All right, so still all the information, you kind of squeezed it together a little bit. It's still all the same information up there, yes?
There's still more room on that page.
Oh, I know, I just made more room. But I like to be able to see it too. So I'm going to write down below like you're suggesting, and I'm also going to write on the other screen. Is that all right? All right, let's try this. All right, I want to make a table. So I have x and I have y. And in the very middle, I'm going to put my vertex, 2, 0, and I'm going to label that V. Is that okay? So I want to complete the table. So what I'm going to do is I'm going to take a number to the left of 2, which a number to the left would be 1, and a number to the right would be
3.
And those should, because it's symmetric, I have the vertex is symmetric over the vertex over the axis of symmetry, this should give me the exact same y values. Okay, and what's one more value this way? 0, and what's a value this way? Everyone feel okay with how I just generated that table? Is the table done? No. So let's take some values and plug it in. So I have, I'm going to plug into our original. I have y equals x squared minus 4 times x plus 4. And what I'm going to plug in here and here, I should get out. So I could plug 3 in if I wanted to, but I think 1's easier to plug in. Okay, so I get 1 squared, which is 1, minus 4 times 1, which is 4 plus 4. 1 minus 4 is negative 3. Negative 3 plus 4 is 1. Oh, sweet, that's a 1. Where else do I have a 1? Because it's symmetric, where else do I have a 1? At the 3, that's also a value of 1. Okay? Now I'm going to use the exact same equation, but I'm going to plug in either 4 or 0. I'm going to either plug in 4 or 0 back into here. Which one seems easier to plug in? 0, yeah. So I'm going to plug 0 here. I plug a 0 here. 0 squared is 0. Negative 4 times 0 is 0 plus 4. 0 minus 0 is 0 plus 4 is 4. If that's a 4, what does this give me? 4. Notice it looks to be symmetric. I'm going about the vertex. I'm going on either side of the axis of symmetry. So let's bring up our xy axis. Can I do that? Let's see. That should work. Let's make it official. All right. Yeah, do what you can to make it good. All right. So let's try, and that goes to letter E. It says complete the sketch. That's D. E is done. Okay, so this is letter E on our information. And then letter F is to graph it. Okay? And when we graph it, there's an awful lot of information that we could go ahead and put to it. So let's start figuring out a few things to plot. The vertex is where? Huh? Where? 2, 0. Agree? Seem okay? All right, so let's use our table of values and start plotting. I have 1, 1. That also works. 1, 1, 1, 1. That works. What else works? 3, 1. So 1, 1, 3, 1. All right. 0, 4. So 0, 1, 2, 3, 4. And 4, 4. Okay. So if I draw this line like this, let's do this. I want that to be drawn. What does that look like? It's a straight line doing what? Going up and down. It goes right to the center. That's my axis of symmetry. No, y equals 2 goes this way. X equals is always vertical. Okay? So this is the equation, x equals 2. That is our, and I made it dotted for a reason. I made it dotted because it's not really part of the picture, though it exists. So if I were to take this parabola and fold it over onto itself, this point mirrors to here, this point mirrors to here, this point mirrors to itself, but you know, this point would mirror to here, this point over to here. There's all of these different points. Now this graph completed gives us 5 total points. One of those points is indeed the vertex. Okay? Some information that we know about this. Ready? Where does it hit the y-axis? Where does it cross the y-axis? Count again. 0, 4. It's crossing right here, right? Which is the point 0, 4. Guys and girls, this 4 right here is this 4 right here, which is my C value. Your C value at every time will tell you where it crosses the y-axis. Though it's not that important of a point, it is a point that you can easily graph. Okay? So your constant is where it crosses the y-axis at each and every time. And that's our first problem. Can we go? Feel good? Now, I'll have all these saved, so if you guys want to take pictures of them later and me come back, I can come back. That's easy. All right. Problem number 2. Let's play around with this one, see what happens. Problem number 2. We have y is equal to 2x squared plus 4x minus 3. Okay? So, item number A. Up or down?
Up.
Up. Why do you know that? My A value is 2. What's my B value?
4.
What's my C value?
3.
Is that okay? So A, B, and C we can do. All right. Okay. I know this opens up because my a value is positive. It's a positive 2. Next step is use x equals negative b over 2a. Use x equals negative b over 2a to find the x component of the vertex. Go. What do we know? What do we plug in? That negative needs to come along to the right. What's b? 4 over 2, which is a constant. What's a? 2. What is my x value? Negative 4 over? Negative 4 over 4. Negative 4 over 4 is? Negative 1. So my vertex is at negative 1, comma, I don't know yet. Where do we plug it in? Plug it in. This is my x value. I'm looking for a y value. I know that y is equal to this relationship. So I'll take that, plug it in there and there. Okay? So I have 2 times x squared plus 4 times x minus 3. Okay? Let's do this. That was an x. What's going to go right here? Negative 1. What's going to go here? Negative 1. Okay? What is negative 1 squared? Negative 1 times negative 1 is? 1. 1 times 2 is? 2. 4 times negative 1? Negative 4 minus 3. 2 minus 4? Negative 2. Negative 2 minus 3? Negative 5. Guys and girls, this is my vertex. So on the xy axis, I'll go left 1, down 5. Okay? If I go down, or if I go left 1, down 5, and my parabola opens up, do you think it'll cross the x-axis this way? So if I come over 1, and you got to go down 5, and my parabola is going to open up, so I'm down here, is it going to cross my x-axis? Yes. So we'll wake Mac up. I think he's praying again. All right. Give the axis of symmetry. What's the axis of symmetry? Axis of symmetry is what? Almost. Make it the equation though. X equals negative 1. Okay, that's my axis of symmetry. X equals negative 1 is a vertical line. Vertical line has an undefined slope. It's the mirror that's going to allow us to fold our parabola over on top of itself. Okay. Let's see. I think we're doing okay. Letter D. Find any roots. Oh, okay. Let's do this. Let's find any roots. So letter D. Let's find any roots. So my magic number is what?
6.
-6. That's my magical number. And in order to get a negative, I need positive and negative. So I have 1 times 6, and I have 2 times 3. Which one of those is going to work that will add to positive 4? Prime? Prime? You sure? Let's see. Hang on. We probably can make this work. 1 plus -6 is -5. No. 6 minus 1 is 5. No. 2 minus 3 is -1. No. 3 minus 2 is 1. We're not going to get any roots.
The answer is straight.
So, as far as we know, this is prime. This is not going to factor. Now, guys and girls, hang on, let's see if we make this work. Where those things factor is where it would cross the x-axis. Still with me? Now let's step back a second. This is a little critical thinking. So this is not going to factor. Do we all agree? We learned a factoring skill. This is not going to factor. We know to call it prime. This vertex is at -1, 5. So I went left 1, down 5. And the parabola opens up. And if the parabola opens up, if we're below it, it'll cross the x-axis twice. But this didn't factor to give us the roots. Okay? Do you think it's possible that we cross at some weird decimal that never repeats?
Yeah.
You know, could it cross at, you know, the intersection of point 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, blah, 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 blah.
Yep.
And we can't find a fraction? So could it be possible that if something was prime, that it makes our roots something called irrational? And if I'll go back to a lower grade, an irrational number is a number that cannot be written as a fraction. Right? So like numbers like pi, 3.14159 goes on and on forever. You can't write as a fraction. Yes, 22 over 7 is very close to it, but it's not exactly it. The square root of 2 is also a number that is irrational because the square root of 2 can't be written as a fraction. The square root of 3 is also irrational. The square root of 4 is 2, that works. Square root of 5 is irrational. Square root of 6 is irrational. Square root of 7 is irrational. Square root of 8 is irrational. Square root of 9 works. Square root of 10, irrational. Square root of 11, irrational. Square root of 12, irrational. I'm just giving you all kinds of irrational numbers in a low set of numbers right now, right? So the irrational numbers actually take up a pretty large region of numbers. So is it likely that a lot of times it could cross the x-axis and not be factored at the same time? So what I want to start thinking about is sometimes we have to think about it. It's a little critical thing that has to take place. If it crosses the x-axis but can't be factored, where it's crossing the x-axis is someplace called an irrational number. And an irrational number can't be written as a fraction. Make sense? Okay. All right, we know the vertex. We know the axis symmetry. We know it crosses the x-axis twice. We're not quite sure where, but we know it does. I think we can make a table. Let's make our table. Letter E. Is E the table? Okay. Letter E. Here's our table. Okay. We have X value. We have Y value. In the very middle of our table, I'm putting what? Vertex. So I have -1, comma, negative what? 5. Close though. Good. It's right up there. Okay. So this is the vertex. Still with me? Okay. Okay. Let's see if we can do this right. One number to the left of -1 would be -2. One number to the right of -1 would be 0. One number to the right of 0 would be 1. One number to the left of -2 would be -3. -2 and 0 should have the same Y value. -3 and 1 should have the same Y value. We're close. All right. Let's see if we can figure this out. So I have this as my equation. What was here and what was here? George, what was here originally? In this parenthesis and this parenthesis from the original. What was there in relationship to that? What value was here and here? X. Good. Okay. So if I take -1 and plug it in, I get -5 out. I could plug -2 in, but to me, I think 0 might be easier to plug in. And it's going to give us the same value, right? All right. So if I plug 0 in, and I plug 0 in, 0 squared is 0. 2 times 0 is 0. 4 times 0 is 0. So I get 0 plus 0 minus 3. What is that? -3. I know by definition that at -2, what also should the answer be? -3. Okay. Now, I could indeed plug -3 in, or I could plug 1 into this original. Which one looks a little easier? 1. If I plug a 1 in here, and I plug a 1 in here, 1 squared is 1. 1 times 2 is 2. 4 times 1 is -3. Okay. 2 plus 4 minus 3. All right. Last step is sketch graph. It's all right, Mac. Sometimes things happen. Let's go one more graph over. I think I have enough information here. I can probably start making my graph. Let's just do that one. Okay. -1, -5. -1, -5. Vertex, yes? Okay? 0, -3. -2, -3. These points are symmetric about each other, yes? Yeah, it's a little skinny. All right, and then 1, 3, 1, 3. And then what? Then what? Like very little. Let's see, he's here. Good. Perfect. All right. So, watch. Did we have any roots that we could find? No. But we set across the x-axis twice. Agree? If I connect my dots, and I connect my dots, do I know exactly where this is and where this is? No. They are irrational. I know about where they're at, but it's irrational. I can't find them by conventional methods of factoring because they're irrational. And in irrational terms, my numbers that I sometimes factor, we called it prime. So sometimes this could be a scenario that's prime. Okay? Axis of symmetry. Axis of symmetry was what? X equals -1. Okay? X equals -1. So I'm going to draw this here. And that's my axis of symmetry. Now this is where the kid, oh, it's a little crooked. Deal with it.
It is a little bit.
We don't judge. Just because I can't write in a straight line, I can't walk in a straight line. If you've ever seen me drive, you ain't safe if you're on the sidewalks. Woo! Yeah! It's just that's my math teacher. See me in a grocery store, I'm horrible.
Hitting other people.
You guys want to know what I do in a grocery store? This is bad. I shouldn't tell you this, but it's kind of funny. Do this next time. It'll entertain you. Just grab something off the shelf, something random.
Oh, and put it in people's carts.
Oh yeah, and as you walk by somebody, it's like, grab like the big can of V8 and put it in someone's cart.
Saw one.
And people are checking out, going, go find like the pickled pig's feet or something, put it in somebody's cart. And just walk away. Because they're like, yes, this is the greatest thing ever. I'm sorry, I should have told you that. Yeah, it takes them out of somebody's cart, put it in somebody else's.
Just steal their entire card.
Or just take it and put it in your cart. They're like,
Put everything back.
Or go shopping, fill a bunch of stuff in your cart, and then when someone turns around, you take their cart and leave yours in place. Sorry, I think things like that are funny. Woo! I feel pretty good. I like what we're doing. You know what I want to start at now? I want to start our notes. Start our notes. I have a worksheet here. Why don't you guys take like 90 seconds, pass out worksheets, tell each other what you need to tell, check that tweet or text or pin or whatever else happens.
I guess I'm looking at that.
Minute left. Minute left. Okay. 30 seconds left.
What will I do with them?
10 seconds. All right, here we go. Everyone have a sheet here for the notes? Everyone have a sheet for the notes? Okay, let's see if we can figure some of these out. Using blank, we'll find the x component of the vertex. Using blank, we'll find this the x component of the vertex. Using blank, we'll find this the x component of the vertex. Using blank, we'll find this the x component of the vertex. What do you think? What is it? Look at yesterday's notes if you have them still. Negative b over 2a. Thank you. Using negative b over 2a, we'll find you the x component of the vertex. That's your first blank up there. Still with me? Use the x component and plug that value back into all of the blank of the original equation to solve for blank. Use the x component and plug that value back into all of the x's.
Ooh, are we playing Badlands?
Yeah, baby.
I love you.
And of the original equation and solve for y. So your first three blanks are this. Your first blank, you use this. Using that, negative b over 2a, we'll find the x component of the vertex. Use the x component and plug that back into the value in all the x's of the original equation and solve for y. Agree? The vertex is the blank if the parabola opens up. Bottom. Or lowest point. Minimum. I like minimum. Minimum. The vertex, so think about it. If the parabola opens up, this right here is the vertex. It's the lowest point. It's the minimum value. If the parabola opens up, or down, if the parabola opens and the blank and the maximum, if the parabola opens down. Okay, the vertex is the minimum if the parabola opens up and the maximum if the parabola opens down. All right, let's make up a Okay, we're going to write this down. Now, I made this one up off the cuff. Not sure if it's going to factor. Not sure if it has any greatest common factors. But we're going to try and work through it. What is my A value? Negative 3. So we're filling this in as we go along. What is my B value? And my C value? Perfect. I love it. Still with me? Yeah. Okay. The axis symmetry is the equation x equals and is blank. No, wait. let's see, we have to do a little bit of work on this. All right. So I'm going to go negative b over 2a, and that's going to give me negative 6 over 2 times negative 3, which is negative 6 over negative 6, which is 1. Okay. Hey, do I have enough information right now for my axis of symmetry?
Yes.
The axis of symmetry is x equals uno. Axis of symmetry x is equal to 1. X equals 1. Mac is a vertical line that has an undefined slope.
Wait, what?
The axis, because you had said you wanted it to go the other way. So x equals a vertical line. It's an undefined slope. Yeah.
So it's x equals 1, and then it says n is a blank.
Oh. Ooh. Okay. All right. So hang on. The axis of symmetry is x equals n is a vertical line. Right?
Yes.
Vertical line? That's the other blank. Okay. All right. So graph the above. Make sure the table of 4 more values. If the graph factors out, then find the roots. Okay. Do I have the vertex yet?
No.
No, I don't have vertex yet. What am I going to do to get the rest of the vertex? I'm going to plug it in here, yes?
Yeah.
So this is an x value, yes? I have a y value that I don't know. This is to find me my vertex. Okay? So let's figure it out. Negative 3, 0 squared plus 6 times 0 minus 4. Hey, what was here and what was here?
Axis.
X's. And I'm going to put what there right now?
1.
1. I'm putting 1 here. I'll put 1 there, 1 there. 1 squared.
1.
1. 1 times negative 3. Negative 3. 6 times 1.
6.
6. Minus 4.
2.
Minus, okay. Sorry about that. Negative 3 plus 6 is 3. 3 minus 4 is 3 minus 4 is negative 1. Do I know my vertex? Okay. I know my vertex to be that. Let me eliminate this for right now. Let's go bigger. Hum if you'd like. All right. It's time. Let's see. Can we factor this? Let's see if we can factor it first. Wait a minute. This is weird. The parabola opens where?
1.
Oh, parabola opens what? Down. Why?
Oh, no.
Negative
That's
3.
No.
Okay, hang on. 1. Okay, hang on. I'm just going to kind of do this for real quick. 1 comma negative 1 is my vertex, yes? And the parabola does what? Opens up or down?
Up.
Down. Why does it open down?
3.
I got negative 3. Hey, remember I said that would factor and tell you where it crosses the x-axis. What can you tell me about this parabola that I just kind of drew quickly up?
It doesn't cross it.
It doesn't cross the x-axis. If it doesn't cross the x-axis, what can you tell me about the factors? It's prime. It's not going to factor out. So, just a minute ago, we did a parabola that did not factor and it crossed the x-axis twice to give us irrational numbers. Yes? And irrational numbers did indeed cross the x-axis, yes? This one's now opening down, and the vertex happens underneath the x-axis. Now it won't cross the x-axis, so this might be something different. Okay, and I just want to keep that little seed going for you guys. All right, let's... Nice. All right, let's figure out our table. X, Y. My vertex is what?
-1.
1, negative 1. What is one value to the right of 1? 2. What's one value to the left of 1? 0. Still with me? What is one value to the right of 2? 3. What is one value to the left of 0? 0 will give me the same value as 2. Negative 1 will give me the same value as
3.
Okay. All right. So we're going back to our original. Y equals negative 3, parentheses squared, plus 6, parentheses, minus 4. Should I plug 0 or 2 in? Which is easier? 0? Okay. Plug in 0 in, see what happens. 0 here, 0 here. 0 squared? 0. Negative 3 times 0? 6 times 0? Minus 4? 0 minus 4? What else gives me a value of negative 4? 2 does. All right. What's easier, 3 or negative 1?
3.
I think 3 might be. So I don't have to worry about it. So I'm going to plug a 3 in here and plug a 3 in here. Still with me? 3 squared is?
9.
9. 9 times negative 3?
27.
Negative 27. 6 times 3?
12.
18. Good try. Minus 4. Okay. Negative 27 minus 8 is negative 9. Negative 27 minus, or plus 18 is 9. Negative 9. Negative 9 minus 14, or shoot. Negative 9 minus 4 is negative 4. Negative 9 minus 4 is negative 13. And this would also give us negative 13. Okay. Here we go. Hang on. Hang on. Shh. Stay with me, guys and girls. God bless you. All right. Vertex. 1, negative 1. Yes? Okay. 0, negative 4. 1, 2, 3, 4. And 2, negative 4.
What the?
Yay?
Yeah.
All right. Negative 1, comma, negative 13, way down here. And then 3, comma, negative 13, way down here. Yay? This parabola does this. Okay? Did it do what we said? Does it open down?
Yes.
Does it cross the x-axis?
No.
No. If it doesn't cross the x-axis, what do you know about the original problem? It's prime. It's that. Ooh, is it irrational?
It could be.
You know what? I'll tell you this. It is part of the irrational system, but it's a larger number system called the complex number system. Because if you went and factored this out and you knew how to factor it out, you would wind up getting the square root of not some number like 2 or 3 or 5. You wind up getting a square root of negative 2 or negative 3 or negative 5. You get an imaginary number. It's a complex number. We're not there yet. Hey, what would my axis of symmetry be? X equals 1. And that's a vertical line that does this. And we'll make it as straight as possible. There it is. There it is. Wow. Okay. I think I'm okay. Oh, yeah, that's what you said. Okay. Guys and girls, I know there's a backside to this. I know there's a backside. Why don't we do this backside on Monday? Guys and girls, why don't we do this for our assignment for Monday? On that first worksheet, worksheet 39 from today, why don't I say I will mark off once you do number 3 and number 4? Okay, because I know a lot of you struggled on that. Now, other things to know. Other things to know. There's 5 Schoology assignments that tonight is the last time that you're going to do it. And some of you have not done it yet. Okay? And there's also a number 6 one that will be due on Friday next week. So utilize that. So I would say that worksheet, number 3 and 4. And before we get packed up and stand by the door, let's kind of review. And I'm calling names. Getting the cards out. Here we go. All right. Darby, yours was on top, goes to the back. Christian. The vertex of a parabola is what point if the parabola opens up like this? Is it a high point or a low point? Parabola opens up. Where's the vertex? High or low? It's at the bottom. Okay, parabola opens up. Vertex at the bottom. Casey.
No.
Parabola is open down.
Yeah.
Trying to make measure. Okay, vertex is a what?
Positive.
High point or low point? Parabola opens down. High point or low point? Here, we'll do this. So we had this, and our vertex is a low point. If it's this, our vertex is a high point. Okay? This is a minimum. This is a maximum. Okay? Gabe, if I had this as a parabola drawn, and I knew that this point here was my vertex, we'll call it, say, 1, -3, what do you feel the axis of symmetry would be? What would the equation of the axis of symmetry be? It is positive. Positive what? Remember, this is the axis of symmetry, Gabe. It's a vertical line. Vertical line is what equation? X or Y? X. X equals what? 3 is the Y component, so that's got to be, axis symmetry is always the X component. Okay? Ben.
Yeah.
If I wanted to find the vertex and I wanted to find the X portion, what little equation do we know that finds us that X portion?
Find X negative B over 2A.
There you go, negative B over 2A. Good job. Angelo, if I found negative B over 2A, let's say we found it to be 7. Still with me?
Yep.
What would I have to do with that 7 to find the Y component?
Plug it in for X.
Yep. So in order to find this Y value, I'm going to plug this in, plug in for X, and solve for Y. Cool. I like it. Sophia. C. If I had this as my grid, no. Go with there. This is my vertex. Still with me? What does this value have to be? 10? What does this value have to be? Perfect. I like it. Kieran. If my parabola does this, and this value, I don't really know, what kind of solution would it be? Starts with an I. Ends with an L. You got this, man. First off, could I have factored my original if I didn't know exactly where that crossed? Let's say I go and I try and factor it, and I get something that doesn't work. If I get something that doesn't work, so these right here would be actually something called irrational. Here's an L there. See, it starts with an I, ends with an L. Should have gotten it. I mean, geez, there's only 8 letters in between. Irrational. Brenna. Can a parabola, when graphed, is it possible for a parabola not to cross the x-axis? Yes. It is possible for the parabola not to cross the x-axis. Now, Tristan, critical thinking here. Of all of the parabolas we have drawn, can you think of any right now that we have drawn that we have not shown to cross the y-axis? All parabolas will always cross the y-axis. Guys and girls, have a great day. I'll be over in my office if you need me. I'll probably need to go grab something to eat around noonish. You gonna go over there, dude?
Yeah.
Perfect.
I'm getting picked up early today,
Yep.
so can I come back?